Today we are going to jump back in time, like way back, over 2,000 years, to explore one of the most important books ever written, Euclid's Elements. We're going to see how an entire universe of mathematical truth can be built, literally from scratch, using just a few simple, rock-solid rules. And it all kicks off with one big question. Seriously, think about it. How can you prove something is true with 100% certainty without just saying, well, it looks true? That's the puzzle Euclid set out to solve. He wanted to build a system of logic where every new idea was built perfectly on top of the last one, starting from the absolute basics. Okay, so before we can prove anything, we all have to be on the same page, right? We need to agree on what words mean. Every solid system of logic has to start with some clear definitions. So let's get our essential vocabulary down for this whole geometric adventure. We're starting with the smallest possible thing you can think of, a point. But don't think of it as a tiny dot of ink. Think of it as a pure idea, a perfect location in space. It has no size, no width, no depth. It just is. It's our fundamental building block.
So what happens when you take an infinite number of those points and string them all together in a perfectly straight row? You get a line. It has length, but no thickness at all. And, this is key, it never, ever stops. You can just keep extending it forever in both directions.
Right, so we have points and we have lines, but where do they exist? They live on a plane. This is our plane field. Imagine a perfectly flat sheet of paper that goes on forever in every direction. That's the canvas where all of our geometry is going to happen.
And here's the rest of our starting toolkit, just to get us going. We've got parallel lines, which are like train tracks that never cross, perpendicular lines that meet at a perfect 90-degree angle, a line segment, which is just a piece of a line that has a start and an end, the radius of a circle, and of course, a good old-fashioned square. With these words, we are ready to build.
All right, we've got the vocabulary down. Now let's have a little fun and put our intuition to the test. A little true or false quiz. The answers might not be what you expect.
First up, picture one single point floating in space. True or false? Only one possible line can go through that one point. What do you think? That one's actually false. Think about it. You can take a line and pivot it around that single point like the hand of a clock. You could draw an infinite number of lines, all passing through that same exact spot.
Okay, next question. Let's say you have a terminated line, which is just what we'd call a line segment. Can you extend it out forever on both ends?
Yep, that one's true, because a line segment is really just a small piece of a much bigger infinite line. So of course you can always keep drawing it out in either direction. Okay, check this out. We've got 3 line segments. Now, let's say we know for a fact that line AB is the exact same length as line PQ. And we also know that PQ is the exact same length as XY. So, does that automatically mean that AB has to be equal to XY? For sure. And this is where things get really cool. The reason it's true isn't just because it looks obvious. The reason is one of Euclid's unbreakable rules, something he called an axiom. An axiom is a truth so basic, so self-evident, that you don't have to prove it. You just accept it as a starting point for everything else. So, we've got our definitions, we've got our basic rules, the axioms. Now we get to the real heart of geometry, using those tools to build an airtight, undeniable proof. It's like we're detectives, building a case one logical step at a time. All right, here's our first case. We're given this line segment, AB, and we're told that point C is smack dab in the middle, which means the length of AC is exactly the same as the length of BC. Our job is to prove, without a shadow of a doubt, that the segment AC is exactly half the length of the whole line AB. So, let's walk through it. We start with the one fact we know for sure. AC equals BC. Simple enough? Now, we use another axiom. If you add the same thing to 2 equal things, they stay equal. So let's add the length of AC to both sides. On the left side, we now have 2 ACs, and on the right, well, BC plus AC is just the whole line AB. So now we have 2AC equals AB. Do a tiny bit of algebra and boom, AC is half of AB. Case closed. Beautiful, isn't it?
That was pretty satisfying. But you know, it brings up an even trickier question. It feels obvious that a line only has one midpoint, right? But how could we actually prove that? How do we know there isn't some second secret midpoint hiding somewhere else on that line?
To crack this one, we're going to use a really clever trick called proof by contradiction. Instead of proving it's true, we're going to start by assuming it's false. So let's just pretend for a minute that there are two different midpoints on this line. We'll call them P and Q.
Okay, follow the logic here. If P is a midpoint, we know from our last proof that 2 times the length of AP equals the whole line AB. Got it. But if Q is also a midpoint, then the same logic applies. 2 times AQ must also equal AB. Now here's the kicker. If 2AP and 2AQ both equal the same thing, AB, then they have to be equal to each other. And if the doubles are equal, well, the original segments AP and AQ must be equal too.
And there it is. That's the contradiction. If the distance from A to P is the exact same as the distance from A to Q, then P and Q can't be different points. They have to be the exact same point. So our original assumption that we could have two different midpoints has to be impossible. We just proved that a line segment can only have one.
This way of thinking is just so powerful. But what really blows my mind is that some of Euclid's rules, his axioms, they're not just about shapes and lines. They're about, well, pretty much everything. They're universal truths.
I mean, just listen to Euclid's fifth axiom. It's so simple yet so profound. The whole is always greater than the part. It's one of those things that's so obviously true, we almost never stop to think about it.
It's a perfect example. Forget geometry for a second and think about a cake. The whole cake is always, always bigger than any one slice you take out of it. It's just a fundamental truth about how the world works, whether you're talking about cakes or money or people.
And that, right there, is the real magic of what Euclid did. It's not just a textbook for geometry, it's a blueprint for how to build solid, certain knowledge from the simplest possible truths. Which kind of makes you wonder, doesn't it? What are the fundamental axioms, the unspoken rules, that you follow in your own life without even thinking about it? Thanks for tuning in.